In this video, we're going to look at applications of rational equations, proportion, and variation. First up, we'll talk about proportions. And we have a couple of definitions we need to go over. A ratio is a comparison of two quantities, usually expressed as a fraction. There's a similar word, rate, that's also a comparison of two quantities, but the difference between them is a rate has different units inside it. Think of miles per hour, kilometers per second, dollars per ounce. We have different units. In a ratio, the units are the same. So we'll include that definition of rate up there. And then the other thing to consider is a proportion. A proportion is a statement that two ratios or rates are equal. In a lot of cases, particularly in algebra, when we are working with proportions, we have one complete ratio or rate, and we have a second one that has an unknown quantity. But we know that these two rates or ratios are equal, thus we have a proportion, and we use that proportion, that equation, in order to solve for that unknown quantity. So let's take a look at the first example. You will need a calculator if you don't have one nearby. As of 2007, Luxembourg and Europe had 1,500 mobile cellular telephones per 1,000 people, the highest rate of any country in the world. If Luxembourg's population is about 480,200, how many cell phones does the country have? So we can begin by looking at this rate right here. 1,500 phones per 1,000 people. Let's write that down as a rate. 1,500 phones per 1,000 people. Remember that, recall that word per means divide. And then they tell us the second sentence, the population is about 480,200. How many cell phones does the country have? Here's that second ratio or rate that we need to set up. We need to determine first where this number is going to go in our second rate in order for these to be equal. Equations are about comparing same things, so we need to make sure that we have like things in like places. Ultimately, what I mean by that is, because we have people in the denominator of the first rate, we also need to have people in the denominator in the second rate. So let's put that in there. 480, 200 people. And then the question, how many cell phones does the country have? Well, phones is on top and we don't know. So let's let that be our variable. Let's let that be our unknown. Call it X, call it P if you want to. Whatever letter you choose, it does not matter. And then we can multiply by our denominators and be able to simplify the fraction into a nice linear equation that we can then solve. I do want to make one note here that sometimes you are taught to do something called cross-multiply, and cross-multiplying does work, but I am not going to use that method because unfortunately, many times students get confused when to use it. You're only allowed to use cross multiplication when you have a proportion like this, and a fraction equals a fraction. Sometimes students mistakenly use cross multiplication when multiplying fractions together, which should be straight across. And so to avoid any confusion for us, I'm going to multiply both sides by the least common denominator of all the fractions in the problem, just like we've seen before in solving rational equations. So using the same techniques that we've seen before, solving rational equations by multiplying by the least common denominator. Doing a little bit of scratch work off to the side, we can break down 1,000 as 5 times 200. And then using that calculator, 480,200, I can divide by 200 and I end up with 2,401. And it turns out 2,401 is 49 squared, or 7 to the 4th power. I know I don't have any common factors with 2401 and 1000, so I'm just going to leave it like that. Our least common denominator must be divisible by both of our denominators in our problem. So let's take all of 1000, and I'm going to keep it in its factored form to make it a little easier to cancel. And then I look over at the 480, 200. So I'm going to come all the way back over here to the left. I already have 200 in my LCD, so I do not need to copy that again. But I need 2004.01. So let's include that in the LCD. We're going to take this number. I'm not multiplying it out. Know that it is 2,401,000. I'm not going to multiply it out though. I'm going to leave it factored so that I can cancel. Multiplying both sides by the LCD. Here we go. So 5 times 200 times 2401 times 1500 over 1000 equals x over 480, 200 times 5 times 200 times 20 times 2401. And remember, we multiply by the LCD when we've got fractions that are whole numbers. When we have whole numbers, we can put them into fractions over 1. And now we can cancel common factors. I know that 1000 is 5 times 200, so I can cancel those out. And I know that 480,200 is 2,401 times 200. So then we have the equation 5x on the right, and using our calculator, 2401 times 1500 gets us 3,601,500. And we can go ahead and multiply that out. The 1500 times the 401. I'm going to bring my work over here on the right because I have a lot of room over here. And now I have a linear equation. I can solve for x. So I can divide by 5 to get x by itself. And then on that calculator, divide that by 5. 3,601,500 divided by 5. 720,300. And that's our answer. But we need to make sure that we have units attached to it so that anyone reading would know what this number stands for. Go back up to the question in the problem. How many cell phones does the country have? The country has 720,300 cell phones. And that's a proportion. Previously, we talked about the recipe for guacamole dip. 5 avocados. If they're advertised at 3 for $1.98, what will 5 avocados cost? And we did a quick reminder that you wouldn't really be doing this in the store. You would likely say, I need 5 avocados. 3 is almost $2, so I know that 5 is going to be less than $4 because 6 would be around $4. And sure enough, we get an answer that is less than 4. It turns out in these proportions that there are 4 different correct ways to write a problem. And those 4 different correct ways are very messily expressed over here. So let me see if I can erase some of my notes from previous classes. Now, looking at this first proportion and each one of the 3 over here, what I want to point out that the fact that there are 4 equivalent equations for proportions is that as long as we have like things in like places, we can get an answer to the proportion that is correct. So for example, in this first one on the left, I have avocados on the top, and I have their corresponding prices on the bottom. And if I look in the first proportion over here on the right, I again have avocados together, and I have prices. The fractions are just inverted. They are the reciprocals. But I still have like things in like places. If I look at the next 2 equations, you can see that we have the avocados in one fraction and the prices in the other. But again, it goes back to like things in like places. 3 avocados are $1.98. 3 avocados are $1.98. 5 avocados cost, I don't know. 5 avocados cost, I don't know. So again, like things in like places. Unfortunately, there are 4 equations that won't work. Switch just one of these fractions. Take the reciprocal of just one of the fractions in any of these 4 equations and you get that other bad equation, because like things are not in like places. So just double check before you do that multiplying by the least common denominator that you've got things where they should go in the fractions, that they're similar, and we can set it up correctly. In our next problem, the compass in the illustration is used to draw circles with different radii. For the settings shown, what radius will the resulting circle have? This is an example of similar triangles. So if you remember from geometry, similar triangles, their angles are the same, but their lengths are in proportion. So the triangles I'm looking at are the big one made by the compass, and I am exaggerating just a little bit there. I am exaggerating that triangle a little bit. And then the smaller triangle made from the inner part of the compass. We know one side of the triangle, the small triangle, and we know the base. We also know the long side of the big triangle, and we're looking for the base. We don't know what that should be. And this problem was taken from a textbook, Hussey and Gustafson, I think 4th edition intermediate algebra. So just a reference there that we're using their problem. And so we can set up our proportion. I'm going to set it up with small triangle to big triangle. But again, you can set it up to small length to long length, small length to long length. 4 different ways to set it up. So we've got 2.25 centimeters. This is the short triangle, the small triangle. Side to base. I'm going to call this, I don't know, we could call it X. I'm going to call it R. And then I've got length to base. And again, this is 1 out of 4 ways to correctly set up the problem. We can create a least common denominator. I'll take everything in that first denominator, 1.5. I'll take the second denominator, R is not up here, so let's write it down. And then we're going to multiply both sides by 1.5R. 1.5R times 2.25 over 1.5. 6 over R times 1.5R. And then we can cancel common factors. 1.5s will cancel on the left. R's will cancel on the right. 2.25R equals, get that calculator out. 6 times 1.5 is 9. I don't do arithmetic in my head. I don't trust myself. It's all good. And now I've got to isolate the R. I need to get R by itself. R is being multiplied by 2.25, so we need to divide by 2.25. But whatever we do to one side, we need to do it to the other. And we end up with R equals 4. And we think about what radius will the resulting circle have. All the settings are in centimeters, so R must also be in centimeters. You try the Washington Monument problem on your own. Check your answer with my OneNote later on if you'd like. See if you can get the correct answer setting up that proportion. Now let's talk variations. There are 3 different types of variations that we're going to look at. The first one is called direct variation. X and Y are 2 quantities, and we say that Y is directly proportional to X, or Y varies directly with X. If there is a number, not a 0 number, K, such that Y equals K times X. So there's some number times X that will give you Y. This is what we mean by direct variation. K is called the constant of proportionality, or the constant of variation. Similarly, if we're talking about your wages for your job, we can create a proportion for your wages. $12 per hour, okay. Then our pay is proportional to the number of hours we work. The more hours we work, the more we get paid. So that's that direct variation. When one variable goes up, the other one goes up too. And if we were to multiply this proportion by the least common denominator, h, we would end up with this equation, p equals 12h, that we then have to solve. And this is what we mean by that direct variation. Y equals k times x. We're just using different letters p and h. I use different letters when I do variation, mostly because I like to use the variables to keep track of what is what, and using letters that correspond to the quantities given in the problem make more sense to me. So you'll see me use different letters in a little bit. Over here on the side, we've got graphs of 3 linear equations, and in each one of them, we can see the k value that comes up, that these are direct variation problems. Y equals k times x. The second type of variation that we'll look at is called inverse variation. In inverse variation, when one quantity goes up, the other quantity goes down. So direct, both of them go up. One goes up, causes the other to go up. In inverse variation, when one goes up, the other one goes down. And we can see them graphed over here. And similarly as the y equals k times x, we can identify k in each one of these being that number in the numerator on the fraction. But for inverse variation, y is inversely proportional to x, or y varies inversely with x if we can find that non-zero number such that y equals k over x. And the third variation problem we have is called joint variation. Joint variation just means that we have more than 2 quantities that are being affected, 3 or 4 or 5. We can also throw squares in there, and you'll see some of those a little bit later. But the same idea, we've got this constant of variation that's being multiplied or divided by other variables. So how do we tackle these problems? First, we'll write the equation for the type of variation we have, direct, inverse, or joint. The joint variation is going to take some more thought and make sure that we're able to translate the words into mathematical symbols. Usually when we have a variation problem, we're given a sentence that tells us how to find k. So we'll use that sentence to substitute to determine the value of k, and then we solve for k. And then they'll give us a second sentence saying a new situation, and we have to find the new variable. Looking at number 9 on your worksheet, the force of gravity acting on an object varies directly with the mass of the object. The force on a mass of 5 kilograms is 45 newtons. What is the force acting on a mass of 12 kilograms? And again, read the problem more than once. You're not expected to know this right away. So we read it a second time. Force of gravity varies directly with the mass of the object. So gravity varies directly with mass. I'm going to write that down. Gravity varies directly with mass. Notice I'm using letters that correspond to what's going on in the problem instead of using y equals k times x. Again, my preference. It makes it easier in my brain to keep them straight. Varies directly. That's where that equals k comes from. And then we know directly means we multiply k times m. Now the second sentence. The force on a mass of 5 kilograms is 45 newtons. We can take that information and plug it into our equation right now. And force of gravity, force is 45 newtons. Mass is 5 kilograms. And so we can set up that relationship. 45 equals k times 5. And notice, k should be the only unknown in the equation. That was in our step-by-step above. And sure enough, we have that here. So we can solve for k. K is being multiplied by 5, so we can divide by 5. And 45 divided by 5 gives us 9. Don't worry about the units on K. K is a constant of proportionality. We don't need new units right away. Now the next sentence, what is the force acting on a mass of 12 kilograms? So now we create a new problem, create a new proportion problem, except this time we know what K is. K is 9. I can go ahead and stick that in. So for the second sentence, I know what K is, and then I know one of the other two variables. In this case, I'm looking for the force, and I know the mass. So we can put that in. Mass is 12 kilograms, and we can multiply those out. 9 times 12 is 108. And we look back at the units. Units on force is newtons. So the force of gravity acting on a mass of 12 kilograms is 108 newtons. Good job. Number 6, under constant temperature, the volume occupied by gas varies inversely to a pressure applied. If the gas occupies a volume of 20 cubic inches under a pressure of 6 pounds per square inch, find the volume when the gas is subjected to a pressure of 10 pounds per square inch. Whew. Well, this is intermediate algebra for STEM, so you are going to get a lot of science applications here. And let's break this down again. Under constant temperature, the volume occupied by gas varies inversely to the pressure applied. So we can write that out. Volume varies inversely. We're going to put the constant on top. Inversely to the pressure, okay? So we set up our initial variation equation. Next step, look at the next sentence. If the gas occupies a volume of 20 cubic inches under a pressure of 6 pounds per square inch, and even though I'm going to pause there because this information right here, 20 cubic inches volume, pressure of 6 pounds, this tells me how to find K. So I'm going to pause here before going on to the next part of that sentence. The next part of that sentence deals with that second step of that second solving of the equation. So let's see if we can find K. The volume is 20 cubic inches. Pressure is 6 pounds per square inch. So we can plug those in. And K is being divided by 6. So to undo that division, we're going to multiply. And we multiply by 6. Our constant of variation is 120. And then we use that in the next iteration of our equation. So we go ahead and plug K in. Now we can look at the next part of the second sentence. Find the volume. So I'm looking for V when the gas is subjected to a pressure of 10 pounds per square inch. Okay, I'm looking for V, find the volume when the gas is subjected to a pressure of 10 pounds per square inch. I know P is 10, so I can plug that in. Division here, 120 divided by 10 will give us 12. And 12 is our volume. Come back up here into the problem, check your units. Volume is cubic inches. Inches cubed, or you can say cubic inches. Either way you write it is totally fine. And then notice, with inverse variation, P is 6 and our volume is 20. When we increase the pressure to 10, our volume decreases from 20 to 12. So there's that inverse relationship. When one variable goes up, the other variable goes down. Let's take a look at a joint variation problem. This will be our last one. The costs of a trucking company vary jointly as the number of trucks in service and the number of hours they are used. When 4 trucks are used for 6 hours each, the costs are $1,800. Find the cost of using 10 trucks each for 12 hours. So again, looking, costs of a trucking company vary jointly as the number of trucks in service and the number of hours they are used. So we can set up that variation problem. costs, there's our constant. It doesn't tell us inversely or any other words, so this is just straight multiplication. Number of trucks, so we can call T for trucks, and the number of hours, we can let that be H. And then, just like before, one part of the problem tells us how to find K. The next part of the problem will tell us to find one of those three missing variables. So next part of the problem, 4 trucks are used for 6 hours. The costs are $1,800. We can plug those in. So 1,800 cost. I'm looking for K, I don't know K. 4 trucks, 6 hours. Cleaning it up just a little bit, 6 times 4 is 24. And then to solve for K, we can divide by 24. 1,800 divided by 24 will give us 75 for K. And now we take that K, plug it into our variation equation. Cost equals 75 times T times H. And then the next part of the problem, find the costs, I don't know what cost is, of using 10 trucks each for 12 hours. So we know 10 trucks are being used for 12 hours, and we're looking for the cost. And we can multiply that out. 75 times 10 times 12 gives us $9,000 for our cost. Good job. Now go through and try the other examples that are given to you in your packet. See if you can get the same answers that I get. Take a look at the course OneNote to check your answers. Until next time, take care.